I'm Elizabeth. I have been working in data science for about 6 years now. Actually, the first 5 of those were not in the cybersecurity space. I come from like a market research background and have been working now in security for just over a year. When I joined Expel just over a year ago, that's when I started in this space. So today I just wanted to kind of talk through a few of the projects I've worked on in my time at Expel and kind of like the challenges that we're facing and how we're using 3 kind of unique and different data science or machine learning techniques to help address those challenges. So before I jump into actually like what the projects are, I want to kind of set the stage at a super high level of what Expel does. And hopefully then as I talk through these projects, it'll make a little bit more sense like where they fit in to the process. And like Lauren said, I am totally open if you want to ask questions as they go. I would love for this to be conversational. And I'm going to hit, since I'm going through 3 topics in a short amount of time, I'm going to hit them at a pretty high level. So all the more reason, like if you have questions, definitely please interrupt me. Doesn't bother me at all. So Expel at a super high level is the process that we're going through is we're ingesting customer data, which is kind of like our input data. And we are using automated detections on that data to look for suspicious or potentially malicious activity. And when we see that, or when our automated detections find that, we would trigger an alert that would then go to our analysts for review, our security operations center for review. And that's the human in the loop portion where they're looking at the alert and they're actually making the final call as to whether or not this is malicious activity or not. As we send those alerts to our analysts, we're kind of trying to preempt the questions that they might have as they are triaging this alert. So as they triage an alert, they're trying to figure out if it's actual malicious activity or not. And they're going to ask themselves questions and maybe go and look for like additional data to pull in to make that decision. And part of what I'm trying to do and other teams at Expel are trying to do is kind of answer those questions ahead of time for them and add that data to the alert for them. With the ultimate goal of making our analysts more efficient. And all the projects that I'll talk through today have the goal of making our analysts more efficient. We want to make sure stuff is getting to our analysts at the right time. We want to make sure that they're not seeing repetitive, like the same things over and over again. So that kind of sets the stage of like everything I'm going to talk through is with the ultimate goal of just trying to make our analysts more efficient, basically. I probably used a couple of vocab words on that last slide that are unfamiliar, so I just want to quickly touch on these because I'll use them again and again as I talk through the projects. So just to make sure we're on the same page on these, an alert is just, again, an indication of potentially malicious or suspicious activity. And these are what go to our analysts, and they review these alerts to actually make the decision of whether or not it's true malicious activity. And then the second one is triaging, and I'll use that phrase a lot. That's just the process of an analyst picking up an alert, looking at it, and making that determination. So hopefully that helps too. All right, so, and actually let me move this. So the first challenge I want to talk through is this challenge of rearranging our queue. And I'll talk in the next slide more about what a queue is. But basically, our analysts look at alerts in the order in which we queue them up for them. So it's really important to us to make sure we get the most suspicious alerts to our analysts first. So for this project, we looked at a subset of alerts that involved Powershell processes. And we wanted to see for this set of alerts, can we look at each individual alert as it comes in, determine how likely we think it is to be malicious, and then depending on that determination, slot it into our queue at the most appropriate place. So as background for anyone that's not familiar, Powershell is basically a tool on Windows machines. It's a legitimate tool that's used for system administration, but it's also commonly used by attackers who quote unquote want to live off the land just because it's already available on the Windows machine. So again, we're working on this project for the subset of Powershell activity. So basically the goal here, like I said, is to try to slot those Powershell alerts into the right place in the queue. And the way our queue works is we have 4 subsets: critical, high, medium, and low. And then we have internal time objectives, basically, of like if it falls into critical, we want our analysts to look at that within ideally 5 minutes. So the idea being if a PowerShell alert comes in and we think that it's highly malicious, we could slot it into that high or critical queue, and then we're making sure an analyst looks at it much more quickly than otherwise. All right, so super delayed, it seems like. Okay, so how does this PowerShell model work? So at a really high level, and then I'll jump in more detail in the next slides, we are checking an incoming alert to see yes or no, does it have PowerShell activity? If it does have that PowerShell activity present, then we take the process arguments and we run it through this PowerShell classification model. And from there, we're getting the prediction of how likely we think it is to be malicious. And then depending on what that outputted likelihood is, we compare it to some thresholds. And then if it is above a certain threshold, we would reprioritize it in the queue. And then if the alert is reprioritized, it's really important to us to make sure that we're super transparent with our analysts. So we add a note into Workbench, which is where they are triaging alerts and working through the system. We add a note there that just lets them know, hey, we moved this from like low to high because of likelihood of malicious arguments. So the first step in that process, to dig in a little bit more, is again, we're checking for PowerShell processes, and then we take the process arguments. If a PowerShell process is present, we take those process arguments and we extract a bunch of features from those process arguments. So the model has over 30 features that it uses to make the prediction. And just to go through a couple examples to make it make more sense, we would look for counts of occurrences of special characters. So like here you see plus sign, apostrophe, dash, semicolon. These types of characters can be used for obfuscation, which tends to make us think it's more likely to be malicious if they have a lot of those. So we have features that count some special characters. Some other features are looking for just indicators of if they have certain strings in the process arguments. So strings like download, invoke, -enc, which is short for encoded, and format all tend to kind of like make us think maybe this is more likely to be malicious. So we have features that are indicators of that. And then another one is just proportion of uppercase to lowercase letters. And that's, again, just goes back to the obfuscation thing where sometimes mixed cases, if it's a really high mixed cases, that can be an indication leaning towards the malicious side of things. So again, we take those process args, we extract all these features out, and then sorry, this is so weird. Then we run those features through our model. And for this, we're using a light GBM classification model. So if anyone's not familiar with that, it's a decision tree based model. And basically the decision tree, as I'm assuming most of you are familiar, is just working as it goes through the features, picking the path until it gets to the endpoint. Here it's showing this example is just like malicious versus not malicious. We're actually not predicting the flat binary like that. We're predicting a probability of how likely we think it is to be malicious or not, to compare to thresholds to see where we slot it into the queue. And then again, if depending on what that outputted probability is, if it's above a threshold, we will just move it in the queue. And then this is the note that pops up to our analyst where it just says like, hey, for this example, we changed the severity from medium to high because of likelihood of malicious arguments. And that way our analysts are aware that there's some machine learning going on in the background, and it's a super transparent process for them as well, which is good because then they feel like they can come, as we're being transparent about it, they feel like they can come to us with questions or, hey, we don't think this one should have been prioritized or this one should have, and it creates that feedback loop, which is really good and important. So that's the first one at a high level. I'll pause there. Does anyone have questions before I jump into the second project I want to talk through?
Yeah. So is that supervised learning there?
It is, yep. So we are able to get labeled data because as alerts are triaged by our analysts, they make a decision as to whether it was malicious or not. And we record that decision and have that data that we can use later for training models. Good
Do you
question.
guys ever, do you guys ever like randomly triage things that didn't get marked as malicious or suspicious to sort of account for any bias that the model might present in the feedback loop?
Yeah, so there is that not as part of my role, but the actual people, the analysts running the Security Operations Center, they have a process where on a daily basis they sample from the alerts that were triaged, and someone else basically will check and make sure, yeah, I would have come to the same conclusion as the person who originally triaged.
Cool.
Good question.
So you showed a single decision tree.
Mhm.
Is that how your model works, or do you use multiple?
Yeah, so like GBM basically builds multiple decision trees together. So I can't remember the exact number off the top of my head. I think it's like 600 decision trees. That was the final count that we picked for 600 about. And kind of the way it works is like um, one decision tree will be made, and then the model sees how much error or like where is there significant error, and the next decision tree in the line kind of solves that error, and so on and so on. So all the trees kind of work together to come to the final outputted probability.
Oh, it's a gradient booster. Right,
Yeah.
GBM, right,
Mhm.
right.
Yeah, gradient booster typically implies a forests.
Yeah, it's similar. And when we were going through this project, I tested just like a basic random forest as a starting point, and then XGBoost and Light GBM. And it was important. We ended up with Light GBM because it was important to have really high recall, and Light GBM just had the best results in terms of recall.
Mm-hmm.
Doing
Quick question.
explainability. Or
Sorry.
Go ahead, Mike.
Oh, I was
Either
just gonna ask, out of curiosity, do you have like any statistics onto like what percentage of attacks exploit PowerShell as an entry point? That's I never heard of that. That's kind of, I mean, it makes sense, but that's interesting.
That is a good question. I don't have that off the top of my head.
I
Yeah,
imagine it must be pretty common though.
yeah, it is common. But yeah, I don't have the number off the top of my head. Sorry.
Another question I had, Elizabeth, great session so far, is so this approach will work really well for security threats that you're very familiar with and you know how they look like, you know what's their feature pattern. What happens with new security threats? What is the process for you guys to collect data and be able to automate it so that it can be classified using one of these models?
Yeah, that's a good question. The process for me, especially not coming from a security background, is working with the people who are, hands on this stuff day in and day out. So whether that's the security operation analysts or some of the people that are actually writing our detections, it's working with them and understanding, like if there was another problem we wanted to approach in this same format and build out features for it, we would have to make sure that that I was talking to the people that know, like, what are the features we should even be checking for. That's a really good question.
And how much training data you need and validation test data?
Exactly. Yeah.
Thank you.
Speaking of sample size, I was curious. I would imagine that a lot of the companies that use this are probably like big enterprise companies because that use like PowerShell for all their IT operations. What would you say is like the typical like headcount size, I guess, of a client of yours? Like, is it like 100+ people, smaller? Like, I'm just curious, like, what kind of scale is required to take advantage of this kind of stuff?
Yeah, it varies very widely. There's anywhere from like in the thousands to in the like tens of thousands plus. So a lot of variety.
So here you're talking about severity in terms of the likelihood of it being malicious, but is there a part in the process where you determine how impactful it could be if it is malicious?
That is not part of this, but that's a really good question. I think in general, PowerShell can be pretty impactful if it's malicious because because of the way that tool works in general. So it's a high concern to begin with because of that. But as far as each individual alert, trying to determine how impactful, that's a really good point, and it's not something that this impacts. Cool.
This is really neat stuff.
Thank you.
Are you collecting any feedback from the analyst? So for like in this example, you say that you changed it from medium to high severity, but what happens if it was really a medium severity event?
Yeah, so the process for collecting feedback from analysts is, especially as we rolled this out, we just tried to make sure it was a really open process of letting analysts know. Like I worked with them as we rolled it out to explain how it worked and stuff like that. And then we set up a process where if they had concerns, like if they said, hey, this one got moved to high and we don't think it should have, they can just reach out directly to me. And let me know when they're seeing that type of stuff. And they've been really good about actually reaching out and saying when they don't think, like in your example, if it got reprioritized to high and it shouldn't have, or vice versa, if it didn't get reprioritized and it should have, they'll reach out and we can collect that information. And then for future iterations of the model, try to look at that to see, are we seeing like patterns in the ones that the model is missing? And does that mean there's like a new feature we could add or something like that? But it's really just like an open communication line where they can just reach out to me and let me know.
Gotcha.
Cool. Any other questions before I jump to the next one? Alrighty. Okay, so this next one is, so first one was all about like a machine learning classification model. This one is focused on some time series data and how we handled that. And the challenge here was wanting to avoid over alerting on time series data. So if the data, if like we're seeing typical patterns, even if they're spikes, if they're typical, we don't necessarily want to alert on that. So for this project, we wanted to find what is like typical behavior, and let's make sure we don't alert on that to try and get some alert volume down to avoid like alert fatigue and stuff. So the graph here basically shows time-centered data, and the line that you're seeing is counts of events. And for anyone that's familiar, this would be counts of failed logins. So that's like someone tries to log in, they fat finger or whatever, and it fails for some reason. And you can see in this graph that there's a very repetitive pattern. You can see a daily repeated pattern where it spikes and drops and spikes and drops and spikes and drops. Some days there's like a really significant spike, and some days it just looks like a typical pattern. And so we wanted to find a way that we could make sure we're alerting when the failed login volume is high enough to be concerning, but not when it's just typical, like let's say everyone got to work at 9 a.m. and several people fat fingered their password or something like that. So the methods that we used for this was a combo of seasonality decomposition and an ESD extreme studentized deviate test, like a version of that basically. So the seasonality decomposition piece basically takes that graph I just showed on the last slide and decomposes it into three pieces: the trend, the seasonality, so that repeated daily pattern that we see, and then residual, which is just what's left over that the trend and seasonality pieces didn't pick up. Once we've done that, we run this ESD test on the residual values. The variation of ESD tests that we did is called hybrid seasonal or seasonal hybrid. And basically seasonal is because we're doing it on the residuals after we've taken seasonality out. And then hybrid is because when we're calculating our test statistic, rather than using like your typically we would subtract mean, divide by standard deviation, instead of using mean and standard deviation, we're using the median and a value called MAD, which basically both of those are just substitutes that are more robust to outliers, since the whole point of this is to find outliers. Okay, so let's walk through an example of how this looks. We're gonna focus on this point in the black box here, and we wanna know, is this a true anomaly or is this just falling within like a typical daily peak? So step one, like I mentioned, is we're gonna do this seasonality decomposition. So we're breaking this into the trend, which is that second graph here, the seasonal, which is the daily repeated patterns, and then residual, anything that's left. And you can see in the residuals here, like we're getting a few spikes, and those are gonna be the things that get marked as outliers. So what we use a 2-week look back. So we're kind of saying like, is this pattern out of character for what we've seen in the last or is this particular point out of character for what we've seen in the last 2 weeks? So once we've broken out just the residual, that's what we're then going to run the the ESD test on and just see, is this a statistically significant spike?
Can you speak a little more as to why you picked 2 weeks?
Yeah, there was just some testing. We wanted enough time that we could see actual patterns, but we didn't want, like, let's say a holiday fell in that time or something like that. We didn't want it to be so short that that could potentially like sway the results. So I think I tested like 4 weeks, 2 weeks, and 1 week, I think, and 2 weeks came out as having best results when compared to like some actual malicious events that we could compare against. Okay, so this is like a representation of running that ESD test. Basically, the blue distribution is we make the assumption that our residuals would be normally distributed after removing trend and seasonality. And then the green line is where we would expect, that's like where we're saying anything beyond this, we're gonna call that an outlier. And then the red value, that red line shows actually where the test value fell for the point that we're talking about. So obviously, yes, we're calling this an outlier. This one you probably could have picked out visually, but I'll show you in a couple slides some of the less obvious ones. And then this shows just kind of like what was the impact of that research. So the first graph is the same one I showed on the first slide about this project. Again, it's volume. So if we, with the original method, there's just like a flat threshold where we say, okay, anytime failed logins for this customer fall above like 500, for example, we're gonna alert. And when we used that hard-coded threshold, our analysts were getting in a 3-month time frame about 4,500 alerts. And then using this method, it reduces it down to about 156 alerts in that same time frame. And you can see the red dots are where it actually alerted. And especially in this case, you can see there are still some clumps where we could probably do more there to say, like, if 3 hours back to back are all getting flagged as outliers, let's like clump it together and make that one alert. For example, there's still more that could be done there, but a pretty significant reduction in the volume. Does anyone have questions about that one before I jump into the next project?
Yeah, so this specific data set, was it, so the values that are older, they were based off of past data, right? So you were using 2 weeks before, like say the 27th, to compute all alerts up into the 27th.
Yep, exactly. So it's like a rolling window. So this one is just easy to spot on a screen. So like for this outlier here, we would have been using probably like this chunk of data-ish, like 2 weeks. It's a rolling window. So each point we're evaluating, we just pull the 2 weeks prior to that, run the seasonality decomposition and statistical test on that 2 weeks, and then say yes or no, we should flag it, depending on our p-value thresholds and stuff.
So do you think there could be like some lingering effects? Because I'm looking at this cluster between 26 and 27, and it seems like the alerts are a lot lower than, say, the 0209 cluster. So it almost looks like if you have like a period of high activity, that decreases your future likelihood of having an alert at a lower level.
Yeah, it definitely would. And that goes back to like, how long do we set the threshold? 2 weeks, 4 weeks? Because, for example, like you can see at the end here, in general, it starts to pick up and be higher. That could be like this customer maybe hired more people, and so the volume is getting higher. So we would want to make sure that like we're to an extent actually capturing that, because it could be true behavior that volume is actually just like rising at this point. Does that answer your question?
Oh, sorry. Oh yeah.
Okay.
Yeah, that was my observation as well. You said there's an uptrend in number of incidents after 02. Not only that, but they're also closer to each other. So I don't know if there's any way for you to detect that as well, that there's more, but also closer to each other.
Yeah, that's a good point. Like if we're having like 3 back-to-back hours that get flagged, that's a really good point. Yeah, I think there's definitely more that could be done when we see them clustered like that, to try and either, whether that's like we need to look into this more and provide that potentially as decision support for analysts as they're looking into it, or if like multiple happen at the same time, not having multiple alerts. Yeah, I think there's definitely more that could be done there for sure.
Yeah, and the uptrend is also of concern. So you need somebody to manually look at it, I guess, to make a decision if this is a valid case, or this is just a increasingly repeated number of incidents?
Yeah, that's a really interesting point. And actually, as you're saying that, I'm wondering, like, maybe you could combine this with like a change point analysis, where if there's a change point, someone needs to manually look, confirm that that's okay, or like, hey, this is the explanation, and then we continue running.
I presume you're looking to optimize for false positives in this scenario. What kind of tools are you using to do this with seasonality?
Yeah, so this was done using like a package SciPy stats model, TSA decompose, I think is what it was called. And that package does the decomposition for us. It's actually like that portion is super short code wise.
Is there any consideration for outside features? Like, I'm imagining in terms of IT practices, whether there's a regular schedule to having to change your password and whether that might affect some of these flags.
That's a really good, we don't have anything built in like that right now. That's a really interesting point too. If we could somehow like get that information ahead of time, that's a really good point.
So I don't know if you've heard of this package, but Facebook has this package called Profit. And that has a similar decomposition with the ability to also have what you call holidays. So if you know in advance that every 6 months or on specific days your passwords will expire, you can set up as a holiday, and basically it's not live, it's an external event that shouldn't misclassify your model.
Okay. I have played around with Profit like a very small amount, but not enough. So I'll definitely check that out.
Yeah.
Cool. Any other questions about this one?
Do you guys profile users? Like, I was going back to the one with the logins, like, do you potentially control for like people who are always bad at logging in?
No, we don't. I think the concern there would be like, what if it's like the boy who cried wolf, I guess, but what if they do actually like that account has malicious activity?
Or maybe they're more likely to be attacked if they're the type of person who.
Oh, I see what you're saying. Yeah, that's an interesting point. We don't have any anything like that, at least not that I've worked on. But that's an interesting point. Cool. I'll jump into the next project. So the last one I want to talk about is trying to reduce repetitive work for our analysts. That can obviously be like tiresome when analysts are looking at the same thing over and over again. So we're trying for this project, the goal was basically just to reduce repetitive work for them. So in this, the goal was identifying any phishing email alerts that are the same or almost exactly the same as something that they have already triaged, basically. And for anyone, just as background, for anyone that's not familiar with phishing, that's just like a virtual attempt at getting someone's like secure information through email. So the goal for this was basically customers will submit emails to us that they think are potential phishing emails. And sometimes what this looks like is we were seeing like a lot of repetitive data in this, because sometimes what this can look like is, let's say a company sends off a marketing email and they send it to like everyone at a company. And let's say half that company thinks it's a phishing attempt. So all of those emails are getting forwarded as what people think is a phishing attempt. And so our analysts are having to look at that same email over and over again, because it's coming from different people, even though it's the same email. So the goal with this was basically, we wanted to inform analysts if there is a similar email that's already been triaged to the one that they are currently looking at. And this is an example of it where you can see the email. I've blocked out like some like company names and stuff, but the email is essentially the same contents. It's addressed to different people though, and it's signed kind regards from different people. But body of the email otherwise is exactly the same. So these are the types of ones we want to identify, where if an analyst is looking at this one on the left, we can point them and say, hey, you already triaged this one on the right, and they can look back and see like what they did to triage that one to hopefully help speed them up. So the method we used here is basically a new email comes in. We extract from that email the body, any domains, any attachment types. And then we process the text of the email body. So some pre-processing would be like removing headers and footers. One example of this is like, you know how if you send an email from your iPhone, the default is it says like sent from iPhone. We wanted to extract anything like that because we didn't want emails getting grouped together just because they had like that kind of text. Then after that, we extract word embeddings for that processed email body and calculate a similarity score. So we can then return the email with the highest similarity score. And those two in the like bolded boxes is kind of where I'll focus talking through. Oh no, are you guys able to see the content here or it's not showing up? Okay, I don't know what happened. It disappeared for me too. Basically what I was trying to show here is an example just of like a toy email. So like to show that if you have an email that comes in that says like, hi, my name is Elisabeth, we would search our corpus of all past emails that we've gotten from, in our case, from that same customer. And we would look for ones that might say like, hi, my name is Bob. Hi, my name is Joe, and return basically based on similarity. Sorry about that. I'm not sure what happened to the slide. There, it finally pops up. So the first step is once we do all that pre-processing and like scraping away some of the text we don't want, we basically turn the email into, we get the BERT embeddings for it. What's really cool about this is like the BERT embeddings already exist. So some machine learning models, there's like a burn-in period, right? Where you have to collect data that you can train a model on and that kind of stuff. So because we're just using the straight BERT embeddings as they exist, there's no burn-in, which is really great for this particular case. So we just turn that text into the BERT embedding as the first step. And then the second step is just a semantic search for matching. So we do semantic search based on cosine similarity and cosine distance. So once we have these BERT vectors for every single email, then the newest incoming email, we calculate the BERT vector for it. And then we do cosine similarity against the other ones. And then it returns the top most similar email. So this is a cool example because if you visually look at these, they look different, but the body of the email is almost identical. And so this one comes back with a 91% similarity score. That's the highest similarity. And so we would basically, when the analyst is looking at this one on the left, we would surface and we would say, hey, that's really similar to this other one that you've already looked at. And then they can use like any efforts they put into triaging the one on, they put into triaging the one on the right to help them triaging the new one. And I think that is it for that one. Does anyone have questions about that process?
Could you just elaborate? I'm sorry, could you just elaborate on BERT a little bit? Because I'm not familiar with that.
Yeah, so BERT, I can't remember who it's trained by. I want to say Google maybe. It's just an existing embedding library. So basically you can just like download the BERT embeddings as they exist. And they have a few different variations of it that have been optimized for different things. So the particular one I used here was optimized for like text similarity purposes. And the BERT embeddings already exist. So basically what that means is like the word embeddings are finding words that are similar, even if they're different actual text. So if you have a sentence like, the queen is good, and another sentence, the king is good, for example, like the BERT embeddings for those would be fairly similar because in the training of BERT, it learned that like king and queen often are found together. Those have like similar context essentially. So the BERT embeddings are basically just a way of turning text into numbers in such a way that we know if the text is kind of like similar based on context. Does that make sense?
Yeah, is it an RNN? Is it yeah. I guess I'm kind of more curious about the architecture.
Yeah, I'm not sure off the top of my head. There are a ton. I don't know if you guys use like Medium for understanding stuff, but there are a ton of BERT articles on Medium. Anything from like high level, kind of how I just explained it, to more detailed on the architecture and stuff. And then there's a lot on GitHub in terms of like, one, if you wanted to see the detailed code, but also there's a lot just like on GitHub to see kind of like in more detail if you wanted to learn about the different subsets of BERT, of how it's like been trained for different purposes and stuff like that.
Yeah, it's built on an attention mechanism, which uses highly parallel operations to look for similar words in a context. And there's many variations of it, by the way. This is Probably, I don't know
Yeah.
which you use, but there's so many of them.
They're like hundreds of variations. It's one of the most popular NLP models in the past
Yeah.
5 years.
But my question is, usually these models have been trained on like Wikipedia or online sources, and I don't know how your training corpus is, like what kind of special keywords does your training data set include? So those might not be properly matched with this approach. So you might have to do some kind of fine tuning. I don't know if you've thought of that.
Yeah, so I know it's really common, right, to like use BERT as a starting point and then do some transfer learning on it for specific to your use case. We didn't end up having to do that, actually. The results using it straight out of the box ended up being really good. Obviously, it's something like we'll monitor moving forward, but I think the variety of types of text you see in because this is specific to emails, I think the variety of text you see in emails maybe is why that helped. It's not like a cybersecurity specific topic, you know, which I think is maybe why we didn't have to do any of that transfer learning, at least as of yet. That definitely is something we could look at in the future, though.
Cool.
So I know that BERT is a sequence-based model. Did that factor into creating your word embeddings? And if so, since we're talking about emails, they can be up to, I would assume, like over hundreds to maybe several hundreds of words long. Did you have to feed those like sequences of that length into your model in order to create the embeddings?
Can you explain what you mean by sequence?
So when you so if you think of like a classical bag of words type model, all you really care about is what the word is. You don't care about where the word is. So it could an embedding that occurs in the front of a text is the same as an embedding that occurs in the back. Whereas a sequence-based model, where the word occurs matters a lot. And so you would think of something like a name that occurs at the end. Well, that could be kind of like a I don't know what you call them, like a kind regards vis-a-vis this person, or like a greeting that occurs in the front. Well, that would be considered pretty normal if you're talking about natural language. So a sequence-based model would take that into account, whereas a non-sequence-based model like bag of words just I forgot the like word to vec that wouldn't really matter.
Yeah, so the good thing about like closings and openings is we stripped all of that out. So like, hello, Bob, gone. We stripped it. Kind regards, Mark, you know, all that. We stripped all that out. There were some, like at one point I played with including, like if an email has domains included in it, we wanted it to pick up on that in some cases. So like I force moved that to the beginning of the text so that it would pick up on that first. So there was like some playing around with that, but largely didn't have like too much trouble with it being sequence based.
Do you guys have a different version of the product that looks at, because you said that you guys strip out the headings and the beginnings and the end, but like, do you guys have like a different version of the product that looks for malicious like header code?
What do you mean?
So keep in mind that I'm actually not super an expert in this area, but I believe that sometimes like if you're trying to mask like the true identity of your email address, there'll be a modification in the header code, and that's how a lot of I at least have people or like phishers pretend to be somebody else's by modifying the header code.
Yeah, there are, our engineering team put like, definitely not as part of this particular like subset of identification. But I know there was like some additional stuff our engineering team did around like dealing, like parsing out the headers and stuff, but I'm not 100% positive if exactly like what all the rules that went into place for that are.
I feel like it might be trickier for a hacker to write an original email than it is to maybe do a trickier piece of code.
You mean like they would have repetitive ones?
Or maybe actually from a cybersecurity standpoint, maybe like looking for variations in the text is actually more effective than looking at the header, because the bottleneck for like a scam operation might be finding people who can write creative emails.
Yeah. Yeah, from talking to like the analysts who are triaging these, apparently like phishing emails tend to be kind of like short and to the point with like a link they're trying to get people to click on. So they definitely have like a different look to them.
Have you found any trouble specifically with emails that are shorter in length compared to longer in length in terms of finding these similarities?
No, that was something that concerned me a little bit in the beginning, because obviously like a longer email is going to have to match on more to be more similar than a shorter email. And the testing we've done so far, it hasn't been a problem. I think largely because because the pre-processing is like, obviously that's a really important step. Because we're knocking out like the hellos and the kind regards and any email signatures and stuff like that, we're still just like making sure it matches on the body. The biggest concern for a short email would be if it's like, hey, can you check this attachment? We don't want to like say those are similar. So we did, this is in place. And then we had to set a couple additional rules on top that say things like, if they have attachments, don't match it because of that kind of case. If the domains don't match, if like certain domains don't match the emails, that kind of thing, for like those exact cases.
So just a heads up, we are kind of getting close to the time to wrap up. So Liz, if you're okay with it, we could take maybe 1 or 2 more questions.
Yeah, sure.
Anybody else? Okay.
Can you speak a little bit about the process for handling new types of attacks as they are sort of identified, in terms of like getting this to what we're seeing now, from like having first seen what these attacks look like?
Yeah, I can speak a little bit to that. Largely, I think the data science piece usually comes a little bit later. So our detection engineering team is really more on the forefront of like identifying those new types of attacks and making sure we have those detections that I mentioned in the very beginning in place to capture that type of activity. And then the data science piece more comes in like trying to build on efficiency. So like if we have alerts that are just like really high volume or something like that we want to try to improve, then that's more where the data science piece comes in, as opposed to like identifying those like new ones coming out. As of right now, at least, that's kind of how it stood. Any other questions? Thank you guys for all the questions as we went through. I'm really glad it was like more conversational like that. So I appreciate all the questions.
Thank you for the great session. Very interesting.
Yeah.
Yeah, awesome.
Thank you for the session.
Nicholas, I think you had a quick announcement you wanted to make as far as sending out a survey and that kind of thing. So I'll pass it off to you.
Sure. Yeah. Thanks, Lauren. Yeah. So I guess one thing we wanted to see, because this is a pretty different style format for webinars. We wanted to get your feedback on basically the presentation and basically the whole event. I mean, it seemed like it was pretty, pretty solid there. We have in the comments, George actually added one of the cool communities a part of. So I think it went pretty well. But again, at the end of this, we're going to send out a short survey. And if you complete that by the end of the day, Thursday, you are entered into an $100 Amazon gift card. I know I've been using Amazon a ton now that we're all at home. So, and I think, is there 1 or is there 2 gift cards, Lauren? There's 2. Okay, there's 2. So
pretty good odds.
Pretty small sample size here. So definitely fill that out. And thanks for everyone for coming. Again, I just wanted to leave it on this note that, if you have any more questions about Expel, if you think that, we could be a good fit, we're a SOC as a service. So if we're a good fit for the company you may work at in the future or your team now, please reach out to me or Liz. But, I think this was a really good networking and learning opportunity.
Yeah. Awesome. Well, thanks everybody for joining today. I'll be sending out an email with follow-up info, including the survey and everything. So really appreciate your participation. So, awesome. And thanks, Liz, for a great presentation.
Of course.
Great. All right. Well, have a good work day, everybody.
Thank you. Bye.
Bye-bye.
Thank you.